new business opportunities under the new transformation. In this regard, Dr. Tiberius has a very in-depth research and practice. His company SKS has been actively transmitting to us the latest concern from the European industry and customers, and helping us understand the industry trends. I hope all of us can gain something from his report and also get new inspiration from his next report. Please, Mr. Tiberius.
Hello, can you hear me?
Yes, yes.
Hello.
Yes, you're so cool. Yes, please.
Good morning, good afternoon, everyone. My name is Tiberius Ignat. Thank you for inviting me here, Nancy and your team, for inviting me and our company to give a presentation here. Our presentation will be, as Nancy mentioned, more about the trends. We are relatively new, working with CNKI, and from the beginning we mentioned the particular trends that are happening in Europe, and probably each continent could say about their own particular trends. But I'm speaking about the European trends because probably it's interesting for your team, Nancy, and for the team of distributors that are today here with some impressive presentations we already saw, to learn about these trends and maybe to think how are they connected on your own regions. So we are a small company which works with research organizations and publishers to disseminate trustful knowledge and to make the transition to open science. We have the ambition to keep misinformation at bay. We think that misinformation is now a real danger which is happening throughout the spectrum of information, but in particular is getting more danger misinformation related to scientific information. So we will speak today about the open science and the culture, the movement, and the changes that it requires. The research culture in general and the culture which stays behind open science hasn't been discussed enough. It has been discussed a lot about open access, but the culture which stays behind open science haven't been discussed. So this is the cultural part of my presentation. Before we go further, we need to understand the secrecy of science. And no culture, like we speak now about the open science culture, should ignore the traditions. And the secrecy of science was and still is a tradition in science. The scientific endeavor was for thousands of years a secret activity. It wasn't a public activity. The Hermetic philosophy that flourished in the Renaissance here in Europe, for example, embraced, among others, alchemy, for example, which was a mystical system. It was particularly reserved for initiates, they were calling, to share the secrets of nature. Of course, they couldn't find a way to transform stones in gold, but they part of their work, they unveiled a number of secrets which were reserved for initiates. Then the system further discouraged the dissemination of craft techniques, which were part of science, or they were derailing from science. And these artisans' workshops, they were characterized by the absence of sharing the knowledge. The same, for example, Da Vinci was using mirror writing. He was not writing normal mirror writing to cipher his own knowledge that he wanted to pass to specific people. Only the technology of printing finally brought some sort of open science, because through printing and through the ability to share the knowledge with others, and also the initiatives like the Royal Society of London or Académie Royale des Sciences in Paris, for example, they made science to become more open. But we have to keep in mind that science has a tradition in secrecy. And we should not ignore that. We should not laugh about this tradition. We should think deep about it and remember this is a tradition. Today, the secrecy persisted in modern science in three forms. The personal secrecy, which is stemmed from the reward systems in academia, for example. You want to keep the secret because you want to publish first and get that reward. And then is the industrial secret, another important part, which is deriving from the rewards which you get as ownership. Is if you own some information and it's only you that know that information and you patent that information, then you can bring some products and services and market, secure some sort of official exclusivity or unofficial, non-formal exclusivity, because you are the only one who knows how to make that thing. And the third element of secrecy which exists today is the national security and military interest, which keeps some scientific advance secret because nations want to protect themselves and to become stronger. So these three elements are still keeping, so it's not easy, or it's, in my opinion, it's a sign of weakness to say open science, and I don't care about this tradition, I want open science tomorrow. It will not be possible because this is a tradition and we need to respect this tradition. Of course, we need to discuss and to make sure that there is no secrecy in science which is not needed, for example, but ignoring this and not respecting this tradition is something which works against open science. In many disciplines still today, it remains a kind of a black box of how we get to the conclusions. And this is why it's important to understand that the most important part of open science is not necessarily the open access to information, which is shared anyhow, but is shared behind a paywall. The most important part is the openness of the data, which is building new assertions, new conclusions in science. And we have now a number, a big, I would say, for my taste, a big number of discoveries, which are in fact not so much discoveries, but the data set was either truncated or manipulated to please a group of scientists. The Human Genome Project, for example, let's understand what it means when science is open. Was a big deal in the 80s and 90s. Scientists were trying to sequence our DNA, and it was a laborious process. China itself participated in this process alongside Europe, USA, well, I would say Germany, UK, USA, and other countries. And it promised to create medical miracles. There was actually a kind of a race, who is the first which is able to sequence. Universities and research institutions from all over the world cooperated, but there were also other stakeholders, like companies, which were trying to be the first that find. And finally, the government-backed initiatives won, and they were able to sequence the DNA. But then it was a satellite conference. That time there was no Zoom, between Washington and London. And during this legendary conference, Bill Clinton and Tony Blair announced that the completion of first survey of entire human genome. Clinton said is the most important, most wondrous map we ever produced, our mankind. And we learned a new language, the language inside of our body. But it was something else happening at that conference on 14th of March 2000, so 20 years ago. Clinton and Blair popped the biotech bubble by making this genome data free to everyone. So they opened this data set to everyone. What happened? We see here NASDAQ composite, which was where the biotech bubble were measured, I would say. And the investors didn't like that much this idea. of freely available, and they pushed the sell button because their strategy was not on open science. And we see here that was in March 2000, and only in 2017 the market was able to get to the same level. Meanwhile, the loss was $50 billion. So only because that data set, well, it was a huge data set, and that information about the sequencing DNA was made freely available, it produced a loss of $50 billion immediately. So, well, no matter on which part of the barricade someone's saying it was a good thing or a bad thing, it remains a fact. Opening science, it's an important thing. It's a culture that is so significant that can produce such losses or similar advantages in a very short time when it's happening. So we need to handle it with conscious and with respect to what it is in this tradition. I personally, I am very big supporter of open science, but in a responsible way and giving the right respect to the traditions of science. Now, the movement. So we spoke a bit about the culture behind, we don't have that much time. This is normally this presentation is of an hour. The movement that stays before. So first of all, meet Professor Steve Mann from Toronto, and he coined the term in 1998. Although open science, as I described, actually starts with the dissemination of printed knowledge. He emphasized the need for truth and open disclosure, and then he coined this term. He is the father of wearable computers like smart watches, for example, or smart glasses. And he called that, he sees a kind of a hypocrisy in science as long as we don't give access to the data that allows us to come with new discoveries. And for this, he invented, well, he came up with this term of open science, and I highly recommend to read his article, which is a wonderful and inspirational article about open science. But that movement wasn't only by Professor Steve Mann triggered. We have a number of articles, for example, from The Economist, Trouble in the Lab, an article from 2013, How Science Goes Wrong. Roughly between 2000 and 2010, over 80,000 people patients participated in clinical trials, which was later, it was based on new discoveries, which were later retracted because of mistakes or inappropriateness. So 80,000 people participated in edge medicine, I would say, participating in trials just to learn that in a while, the fundamental which stayed on that trial was wrong. And The Economist said, what a load of rubbish. It wasn't the only publication. There were other publications like Nature, which later on came. So this movement started to grow. We have a study from 2016 published in Nature, which is close and is now well known, the reproducibility crisis. So it means they showed that more than 70% of researchers have tried and failed to reproduce another scientist's experiments. 70% of scientists tried to replicate what their colleague did, and they were not able. Even worse, I would say, a large number of them, around 50%, have failed to replicate their own experiments. So 50% failed replicating their own work. What was that? This is a study of over 1,500 researchers. What was the cause of this? 60% of respondents said that the pressure to publish is one of the causes. This pressure to publish pushed them to manipulate a bit the data, to rush into conclusions, not to be completely transparent, just for the cause of being the first that publish. There are other causes as well. For example, the incomplete data sets that they find, or the lack of data of its own that they find from their own colleagues. For many, this study became the trigger to start supporting open science, however it was called at that time. Now we have a number of open science definitions, initiatives. We have descriptions like mushrooms, like spinning wheels, and all of the similars. In Europe, we tend to say that open science is a scholarly research that is collaborative. This is very important, transparent, and reproducible. So collaboration, transparency, and reproducibility of research are the key elements of open science. And I would insist on one, the collaboration, because this is going to address to the tradition and maybe to change that tradition of secrecy. What is not open science, and maybe it's important for us to understand, is that open science is not a surrogate for open access. It's not that the movement started with open access and developed in open science. It's the vice versa. Open science is the movement, open access is just one part of that movement. So it's not a surrogate for, or sugarcoat, sorry, for open access. It's not a snake oil for all researchers. In the Wild West, there were sellers saying, this little bottle is made of snake oil and it will cure all your problems, diseases, and so on, which was, of course, a lie. Didn't exist such a thing. So open science will not cure all the problems in research. It's just one important way to change the culture for better, to accelerate discoveries, and to make this world collaborating a lot more for more solid and better understanding of nature and society. So what we have in 2020, we have a number of initiatives. Many of them are focusing too much on activism. So they are not making the practical steps for open science to happen, but they are making, I would say, the necessary discussion, the necessary even noise, if you want, for calling for open science, asking for people to move to open science. But this is not enough. If you don't make the practical steps, this is really not enough. It's too less change management. Governments and institutions, research organizations, publishers, other stakeholders, libraries, researchers themselves with their own libraries don't understand at this moment at large that we need change management. This change is not going to happen because we want, or because we preach, or because we request it from others. We need to manage this change step by step. The same like we manage a department, like we manage, for example, a production line. We need to manage this change. It is important also to bring the right people on the bus, as it said, the right people on the right seats, to recruit talents, to find them. And this is why it's a complex cultural change. Again, if this movement is not backed by people who understand science, who understand the publishing process, for example, who understand what means data curation, what are the problems to make the data interoperable and reusable. If we don't bring these people in the movement, of course, this movement will move very slow. What are the changes that are needed? So we talked about the culture, a bit about the movement. Please understand this is in a nutshell everything, and the changes. We have one of the changes, it's an example, is the Sorbonne Declaration of Data Rights. I've been part in the scientific committee in this declaration, and I was in Paris when it was signed. I wasn't one of the signatories because there were research organizations and associations of universities, the biggest association of universities in the world, I would say, and they signed this Sorbonne Declaration, which is asking for data to be findable reusable, interoperable, to be to find this data somewhere and to be properly preserved, to be also used, to be shared, to be used by others. I tried to introduce in this declaration, but I failed. I have to recognize data rights not only for humans, but also for machines. Because I explained to my colleagues, we need to think very much in the future, on a very long haul to think, and to understand that machines will work, will be our colleagues and will work next to us. And we need to design rights for these machines. Although these machines won't be intelligent like humans, like beings for making this, but the engineers that are behind the machines could understand what are the rights of the machine that I'm going to build, so that I build a fair, a right machine which is respecting these rights. Unfortunately, I wasn't good enough to convince my colleagues to include rights for machines. Then we have here in Europe Plan S. Some of you might have heard about it, which is a bold change required by founders. So they say, as long as we fund this research and give money for this research, the result of what you find and where you publish should be open for everyone. But there are a lot of challenges to make this. So now Plan S is expanding all over the world. So they try to secure governments to sign and to adhere to accept this idea of opening the research. But it's not so easy. So now they are talking with publishers, and they somehow found a way together with publishers to make publications open, but also to keep the quality in place and to keep publishers surviving, to find a model. What wasn't very much like are the hybrid publications, where you have a journal which is publishing behind the paywall and open access journals, because funders in Europe thought that this way is not going to deliver finally ultimately open access. But if you can read here, the open access foundational to the scientific enterprise. So in the end, the funders want open science, not only because it's ethically important, but it also because it's important for the progress enterprise, so the society progress. So new products, new services, new medicines could be found on the market in a shorter period of time. Then we have the European Open Science Cloud, which is now making it up. It will connect a number of infrastructures in Europe under one umbrella, which will provide fair data to which, as I said, it's findable, reproducible, interoperable data to others. In China, you also have the China Science and Technology Cloud, which was boosted this year. At the beginning of this year, it was brought to a new level with more computing power and more software available to researchers. And they also mention in the description of the China Science and Technology Cloud a connection with the European Open Science Cloud. So we see how continents are moving towards collaborations. Beyond the collaborations that we already have in international articles, where people from China, Europe, Australia, USA, and so on are collaborating together, Russia collaborating together to write articles. But beyond that, should be more collaboration. Some conclusions. We need, first of all, change management. So open science is not something that will happen just because we require, just because we demand from others, just because we tell to publishers, publish open access from now on. This is not going to deliver open science. It requires change management. We need to understand the culture, the movement, and the changes that are required. And we need to understand that this change, huge change, should be managed. What do we think about this? We want to be very clear. We want to live in a world in which scientists have immediate access to the accumulation of knowledge built by a global community. We believe that the public research deserves to be known by all researchers. And of course, we cannot be naive and say that competition should not exist. But we have examples in which pre-competitive collaborations have brought humankind further in their search for solutions. For example, we have collaboration in medicine where institutions are collaborating to find target molecules for new medicines, and they are working together, they are making it open and find these target molecules. And only after they start to compete to develop drugs which are doing something to these target molecules according to what doctors want, to suppress these molecules or to increase the number of these molecules. So they compete in making the drug, but they collaborate in finding what are the target molecules to be addressed. We believe that understanding of nature and society needs to overcome borders and nations. Finding about nature and society should be much more than thinking about nations and borders and countries like this. It's one, in the end, it's one human race. There are not 2, 3, or more human races. Finally, we believe that discoveries should be a collaborative effort at first, and then competition effort. It's a holistic approach, so we cannot have open science all of the sudden and in each element 100%. I would say open science if we have 80% of the data open. If we have, I don't know, 90% of the publications open. If we have, if we change the research metrics in a way which is giving more power to newcomers, for example, for for early careers, for example, which is not putting that much emphasis only on publishing, but puts more emphasis also on the laboratory work, on the way that data is curated, but not necessary to have it change completely. If we change it to a certain level, so each these elements together will form open science and not individually. Sustainability means responsibility. So if someone, a stakeholder, is asking, yes, is saying, yes, I want to change to open science, but I want to be sustainable. This is the responsible way of doing it. If we want to make open science by having some stakeholders disappearing, like, for example, commercial publishers, this is not responsible, in my opinion. We should be responsible. We should understand that everyone can live. They need to change a bit the business model, but responsibility means sustainability. I talked about the change management. It's a big change for science and for society and economy, and this should not be neglected. And it could lead to more autonomy of science, to have less political implication in science, and to have the scientific curiosity. At the core of science is the curiosity to be more autonomous on the hands of scientists, to have more ethical scientists, and then to have them more autonomous in our society. And last but not least, very important, open science doesn't mean cheaper science. It is, in fact, more expensive to have open science than the science that we have now, because making the data set reusable, interoperable, costs a lot of money. Having the European Open Science Cloud, the China Science and Technology Cloud built and maintained with the proper licenses and updates and everything, it's expensive. So open science is not a promise for cheaper science or science that costs less. No, not at all. It's a promise for transparency. It's a promise for open disclosure. It's a promise for more availability of knowledge to others, but it's not a promise for cheaper science. It's actually the opposite. It will cost more, but it's a well invested money. And open science, finally, is not a fashion. We don't say open science because other libraries or other publishers or other researchers are calling for open science. It is something very deep and very important, and starts with an open mind. If our mind remains in the same state of being the first that find, being the first that share, that have a secrecy and not letting others and so on, this is not open mind, and this is not going to deliver open science. These are my contact details. You can contact me also on LinkedIn. Well, Nancy and her colleagues have all my contact details. And thank you very much for attending, for listening. And if you have any questions, I'm very happy to answer now or later. Thank you.
Okay, thank you so much, Dr. Tiberius. Your presentation is very cool and fantastic.